All right, everyone. Hello. Welcome to our third workshop meeting. So happy to see some of y'all here. I know we don't have a full audience, but we'll make it work. But today's main focus is how do we apply Arduino and other microcontrollers of any sort with C++? And how is that going to be useful for world applications? Um, so before I even get to it, I hope you guys are really responsive and kind of talk with me so I can guide you guys, along the way, because it is kind of awkward for me to just talk by myself. I've never been put in this situation, so bear with me. If you guys are ever confused, make sure to ask questions in the chat, and hopefully Andy and anybody else in the board will answer your questions. So without further ado, let's begin. So I'm going to share my screen now. And before I even kickstart, I just want to mention this is not my slide. This is Colin's. So some of you guys are going to be like, bruh, this is not legit. No, this is just an introduction for those who do not know what a microcontroller is. So I'm going to put this in present mode. And just so I can test it, Andy, can you see the whole screen enlarged?
Yeah.
All right, cool. So yeah, again, this is Colin's screen. Please don't roast me. This is just for brief intros about what a microcontroller is once again. All right, so what is a microcontroller? For those who do not know what it is, literally, it is a processor that is self-contained in a system that can be applied into an embedded system, right? So you can honestly see this anywhere and any technological device that we use today. So examples would be in your PC, your laptop, and all of those are, if you look even closer, they're actually integrated in your motherboard. We have these in our phones as well. So if you have an iPhone, great. You have a Samsung, great. All those kind of phones that you've been using since the 2000s, if not even earlier, have been using processors that store in memory, give out data and store it. That's pretty much what a microcontroller does, and it's able to be optimized in the most efficient way based on size. Nowadays, a microcontroller used to be super big, but now it's been like literally the best microcontroller out there could be like the size of, like, if not even smaller than your fingernail, right? So that's just what a microcontroller is. It's super efficient, and it's only going to get better in the future. So um, I'm just reading off the slides here from Colin. These are examples of what a microcontroller can do when it's specialized in Arduino. So, right there, right here, right there, they're in the motherboard, right? They can be also part of Arduino. And Arduino is also used for not only for hardware, but for software as well, right? So there's a lot of things you can do with, I guess, a microcontroller in terms of projects. This could be for professional use or for just for fun. It really depends on you. And so we're going to go through a brief run through of what Arduino is, since that's going to be the main focus of today's workshop. So right here, you have your pins, what you're going to put into connecting it to whatever sort that you're going to code, right? But before you even do that, make sure you have a laptop, right? No dir. Of course, you got to have that. You got to have a USB. I think it's I forgot. It's one of those old USB printers, those cables that you connect it with, right? So it hasn't been updated. It does not have USB-C or a regular USB adapter that we use for our iPhones, right? So we use the old printer USB and we connect it through our laptop, and that allows us to pretty much upload whatever program or code that we integrated with C++ through. So that's Arduino for you. Um, if you look on the sides here, these are what the pins are. You have the power pins, which are around here, and you have your analog pins, right? So your analogs are here, and your power pins are also here. So, and your digital output pins, which is where, let's say you want to put a DC motor, it's going to be around here. But just so you guys don't get overwhelmed, I'll discuss more about that further on in this presentation. All right, and in regards to Arduino, um, we're fortunate enough to have our own IDE, system that when we download it through MacBook, through Linux, or even Windows, it pretty much allows you to have this IDE, which is so helpful because there you can just start off, by encoding whatever you want. And so they give you these basic, setups. You have a setup, and then mainly you have a for loop for whatever you're trying to power, right? Let's say you want a fan, you don't want to like mess around with it and have it spin forever. Maybe you want to control that and regulate it, and that's what a loop does. Setup is mainly just defining your variables, telling what it is, and then applying it to your for loop. In Arduino, you also want to mess around with a breadboard. So this is more into the aspects of electrical. If not, it's kind of getting all these things like wires, resistors, transistors, and whatnot, and applying it to how you can make your project, yes, more extravagant, right? How can you use these to regulate maybe the power or the efficiency of um, controlling your fan speed? All of that is also regulated with and without code. So that's pretty much a nutshell what Arduino has to offer for today's presentation. So I think that's about it. Nope, there's more. These are the applications of what Arduino has for you, right? There's a lot of things you can do. It's not just for powering a fan and whatnot. You can honestly use this with, you know, again, a type of motor that allows you to spin the wheel and kind of you can regulate your code, optimize it in a way where it's trained to be like a car. It can honestly sense anything around, and this will allow you to, you know, uh, have a fun project. You're just gonna enjoy it as long as you set your mind to it. And so I don't want to spend too much time on what you can do, because that's what we're gonna do today. So also that's an L298 motor. I wish I could tell you guys more about it and show you guys today, but I couldn't find it unfortunately through Tinkercad. So we'll just kind of skip over that. All right. So just want to test again. Andy, can you see my screen on Tinkercad?
Yeah.
All right. So right here, this is very simple. This is a DC motor, right? If you guys don't believe me, it's right there, DC motor. Anyways, whenever you're trying to connect it with a battery or a power supply, you're gonna have to deal with a negative and a positive charge or a wire, right? In this case, we have two colors, black and red, which are pretty much universal colors to distinct whether or not it's positive or negative. So I'm going to select one person out of the crowd. Let's see. Colin, which color do you think is positive?
The red one?
How is it red? Do you think it's just red so it's positive? Or is there a reason why or no? Do you just think it's positive because it's red?
Uh, I don't know that, but I do know the black is like to represent like ground or negative.
Right. So yeah, Colin has a point right there. It's like water, right? You don't necessarily explain why water is H2O. You just believe in it, right? So please believe me, red is positive, black is negative. So thank you, Colin, for answering that. That's all you need to know. You do not want to mess around with these wires, especially when they're powered to a battery. If you connect these two together and they somehow touch, that is not good. It will kind of destroy your project, if not blow something up. So you kind of want to tangle them so they don't touch each other. Make sure they're far apart from one another, and your project will run smoothly without any difficulties. And trust me, this is a common issue that every professional has and a beginner has dealt with. So it's something to account for and just try to avoid at all times. And so you guys might be wondering, what the heck am I trying to say? What's the point of having a battery and a DC motor? So today's presentation, we're going to focus on powering a DC motor, right? And allowing it to rotate. That's the whole purpose of today's presentation, and using C++ with it. So if we start the simulation without any code whatsoever, and it's just the DC motor is just being powered by the battery, it's just spinning forever on and on with, if we zoom in, 17,506 rotations per minute, right? It's literally just rotating, rotating, rotating forever until it drains out the battery. So there's a better way to optimize this. You want to make it efficient, because we don't want to drain out the battery if within like 1 hour, right? We want to use this perhaps maybe for a day, if not longer. And so we might want to regulate it with something like a resistor, or another fancier way of saying it, that is also a resistor, a potentiometer. So I'm going to stop the simulation and I'm going to move on to the next Tinkercad that I had. So Andy, can you see my second
Yeah.
model? Okay, cool. So notice here that we use a potentiometer, and now we connect it with two wires. Um, sorry, I heard my voice. But anyways, we connected with two negative wires, one attached to the DC motor and one attached to, again, the battery. So um, kind of think of it in a way where you only need one positive wire in the battery that's connected to both the battery and the DC motor in terms of the negative wires, right? So this allows the voltage to pretty much flow through the wires. And that's pretty much what allows your motor to run, right? So notice that it's running at a clockwise direction, not counterclockwise, because it's being powered through a positive charge, right? So right here, if we crank up the potentiometer, now we're able to regulate or kind of get what we want, right? We get to control the spin rate or the rotations per minute. So though it isn't at 0, it's at 5, and we're able to, control whether or not we want to increase it. We want to, not drain out too much of the battery's power, because if we do this forever, it's going to drain it. But let's say we keep it at 10 or 11 rotations per minute, it's going to be slower, and this is going to help us for projects that don't really need violent, rotations per minute. We want it probably at like, I don't know, 37, maybe it's fast enough from there, right? But let's say we want to turn this off, like kind of like an on and off switch, right? We're gonna move on to this, and it has to deal with Arduino now. So let's say you encode something, and you apply it with Arduino, attach it to your potentiometer, your resistor, and your transistor, right? So I'm gonna click on these so you guys can see on your top right. It tells you what it is. So if I click right here, that's a resistor. And so you guys know what a resistor is. Pretty much it's what allows you to increase and lower your voltage at some points, right? So it transforms the current signal, if you guys can follow, and this allows your voltage to be controlled. It's pretty much regulated. And just like the potentiometer, it's a fancier way of a resistor, just, fancy. And also you have a transistor. So think of a transistor as an on and off switch, right? Let's say when you turn it on, at one point the electric current is like super big. Like it's like a big electric current, and it's like a booster, right? And then the moment you turn it off, it just shuts down. It's like, okay, we're not gonna do anything. Like it's gonna be ground level 0, right? Um, and that's more of like a switch, but it can also be used as an amplifier, right? So when I talked about how it could be, you know, a booster, like it all of a sudden just becomes like it gives a good amount of like voltage, or the current, I mean, that's what an amplifier does, right? So it's kind of like a amplifier mashed in with a switch, so on and off switch with the amplifier. So if you're looking closely, right now, if we set the potentiometer at this spot, right, let's say at this level, it's at 0. And notice, if we do the same over here, if we start here as well, it's at 0 as well, but it's still spinning at 5 rotations per minute. But if we integrate the use of Arduino and we code it somehow, where we define it where, if we use the potentiometer and set it here at this circle, it's not going to spin at all, right? You're going to have 0 rotations per minute. So that is what really divides between having Arduino and having a potentiometer. It allows you to have more features and optimize your pretty much your project in all, right? So now that you can spin at 0 rotations per minute, notice that if I crank it up just a bit, right, it's not even that far apart. It's already spinning at like at a very enormous rate. It's already spinning at like 700 rotations per minute. And if I keep increasing it, it's increasing, but it's increasing in the thousands area, right? And that can only be done if we use Arduino. And if you look here, same thing here. If we increase it a little bit, it's still at 5, maybe 6, and then it just increases all the way until it right here. This is the threshold, and it just exponentially increases. And we don't want that. So by having Arduino, we're able to regulate that because we already set it to like 1,000, right? So it's easier for us. And so I'm gonna stop it there. That's pretty much how Arduino can help power your motor. But now let's talk about how we can apply C++ into Arduino to perform all these features. So I'm gonna go here and I'm going to sketch a new one because we don't want that. I'm gonna share my new screen. All right. Andy, just want to check. Can you see
Yeah.
my? All
Yeah.
right. Cool. All right. So let's start off with the project, right? Shortly after this, once I upload the code and create it, I will show my camera and you guys can see what I upload to Arduino, and this will help you guys understand what the heck I'm doing. So when we start coding, like every other programmer does, you want to educate your audience, right? Whoever's reading your code, they have to. You want them. You want to make sure that they understand what you're writing about, because just like a story, you got to have definition, context before even getting through your plot or whatever makes the the story or the program really good. So let's say we're giving this to someone that will never read this but has to read it and they have no idea. We'll say this code is going to control the speed of a DC fan motor, right? With a potentiometer. Yeah, I think that's good enough. And then let's see. So the first thing we need is we're gonna set variables like int um, speed and whatnot for our inputs and outputs and our mode, right? All right. So now that we have that as our comment, let's start naming what we want to do, right? Let's start setting some variables. So just like in Java, int, right, defines like a number. So let's call it int in 1. And we'll set that equal to 8. And you guys might be wondering, why am I setting it to 8? What the heck is that? Well, I'll explain in just a moment. All right, so the reason why I chose 8 is because this is going to be applied to our pin slots in Arduino. So these numbers 8, 9, and 10 are used for our, I guess, our module pins for Arduino, right? All right. Now that we have that done, we can set up our void, right? So I don't know why I erased it, but they had it all set up for us. And pretty much this is your setup. So now that we have what pins we want to put that into, which is 8, 9, and 10, we got to make sure that, we set it up into a pin. So let's recall it again. Pin model, mode 8, and we'll call this the outputs, right? Because we're trying to get a reaction from it, I guess. Can I get a hello from the chat or something? So I know like you guys are kind of following along. I can't read the chat, by the way. So Andy, can you tell me what's up?
Okay. Colin says hello.
Oh my god.
Tian says hello.
Oh my god. That's awesome.
Winnie says hello, all caps.
Oh my god, this is awesome. All right. People are talking.
Hui says A. King says hello.
All right.
And
So
Colin says, hey, no, shut up, I'm still talking. Carl says hello.
How dare you? Hey,
Victor
this is
says hello.
I have the right to kick you out. You know that, right? All right. Anyways,
Oh.
great. I'm happy that you guys are following along and you guys are still alive. If you guys made it this far, congratulations. Now we're gonna go up with a for loop, right? But before I even talk about a for loop or having a loop, we just set it up. What we really need in terms of having what we want for a loop and integrating or uploading that through our pins for Arduino, right? So yeah, we have all these codes, but how are we going to send them through Arduino if we connect it to our laptop, or like, let's say my PC, for instance? How are we going to do that? Well, by having this set up, now we then have the ability to send whatever we put as an input here and output it out, through our pins, which allows us to send it through our breadboard from our Arduino, right? So let's start with a for loop. So when you want to start with a for loop, make sure you type digital right, because I don't know, that's the way how I learned it. So you should learn it from me too. So we'll just call it low here, right? If you guys have any questions after, I'll explain more about it. But just so we save time, just go along with it, okay? All right, so notice here, we set a variable here, and we said that int1 is 8, right? And we put it here, and now it's called upon. So great, we're not wasting any variables. We're not just, setting them and calling them and saying that and not using them. We actually are. All right, and we just do it for int2 as well, because that one is also another pin that we need to apply it to. So digit, oh my God, digital into high, if I can type. All right, and I was corrected by Andy on this, but yes, it is a variable, analog. Hey Andy, does that spell analog correctly?
Bro, you didn't even initialize speed 1 yet, brother man.
Oh shoot, you're right. We'll initialize it here. Sorry. Speed 1. Oops, that also has to be an int. So speed 1 is equal to, no, that's a variable. Oops. Okay, speed 1 is equal to analog read, right? So just follow along. If you guys have no idea, I'll answer your questions later. Just for the time being, or time's sake, just follow along. So right here, I don't know how to clearly say this, but Andy has experience with Java, and I think it can be applied here. But Andy, do you want to talk about how that speed 1 is applied when you multiply it with any
Bro, I don't
type of
even
number?
know how it works in C++. But
All
like
right.
if you're trying to multiply an integer with the decimal to get a decimal out of it, it's just going to get truncated. Either that or it'll cause a compile error. But you tried it earlier, it didn't cause an error, so I'm sure it
Yeah.
works.
So let's say you want to set it with, you want to make what the speed is, like with a specific type of number, right? We'll just multiply it with, I don't know. My favorite number is probably like 3.14, 20, 68.9, right? Great. Now I have that. Always make sure you have a semicolon. And you guys, probably some of you guys who aren't focusing, I'll tell you guys what this is, right? So this allows the potentiometer to calibrate it, right? And now I'll explain more about low to high. So low and high is used for changing the DC fan motor's direction, right? So if it's low, it's gonna go, I hope it's counterclockwise, and if it's high, then it's clockwise, stuff like that. And it's adjusted with our potentiometer, so it works out, right? And lastly, we need one more thing, and that thing is another analog. And so Kane, where was Kane? Oh boy, I'm missing a lot of things.
Is it because you called it in 3 instead of Kane?
Yeah, it's fine. Speed 1. And this one allows us to upload all, no, not upload, but use our motor. And all, that really helps us with our motor. So I think that's about it. If I am going to check this and verify. And 3 is wrong. Actually, you're right. It's con A. Whoops. Silly me. No, it's not. Wait, it's another one. Semicolon. Void loop.
You're missing the closing bracket on your loop.
Oh. All right, cool. There you go. Thank you, Andy. So yeah, that's pretty much how you basically power a basic DC motor. And I'm gonna upload that. Oh, you guys can't see me uploading. Or can you? Sure. All right, cool. So I'm gonna stop sharing my screen and I'm gonna show you my actual camera. And before I do that, let me just clear out my table so you guys don't think I'm messy. All right, cool. Can you guys see my screen or my video?
Yeah.
All right, cool. I'm just gonna clear the table. All right, so pretty much this is your breadboard that I was talking about, right? You have your Arduino, and this is a 12-volt battery that's pretty much put together with 1.5 volt batteries, right? So 1.5 times 8, I'm assuming it's 12. So that is able to power my, I guess you can say this is a DC fan blower. And right there, that's an L298N motor driver. And that's the thing that we're going to use to help, apply this through here and then through the Arduino, right? And we also have our potentiometer, which is something that I was trying to tell you guys, that is kind of like a resistor. Notice we don't have a resistor in the breadboard at all. This is just the resistor itself. So by having this, we just uploaded the code, and now we just got to see if it works. Trial and error. And if it doesn't work, well, oh well. So if I can. Hello? Okay, cool. I don't know if you guys can see it spinning, but pretty much the fan is just spinning, right? And it's blowing cool air. And so if you want to slow it down, it slows down. You just got to turn it whichever way it optimizes the fan to either increase its speed or decrease its speed. So pretty much that's pretty much it for today's workshop. So I'm gonna stop sharing my screen because I don't want to show you guys my arms and anything like that. So today you guys learned pretty much how to apply C++ to Arduino and how to use Arduino with other components like a L298, I guess a driver board, even though you guys didn't really get to see that. But you guys got to see how a transistor works, how a resistor is applied. What else did I talk about? Transistors, resistors, potentiometers, the use of a battery, power supply, not messing up anything when it's negative or positive, setting your variables, creating a for loop, and defining them. So adding comments. So, all right, I hope that, is a good way to end it off. If you guys have any questions, feel free to stay back, but that's all I have to share. I'm going to stop recording now.